Hello, everyone. Welcome to the last session of the Java Code Camp. If you like coding, then you've come to the right place. This is the fourth and the final session of our Java Code Camp on functional programming. For all of you that don't know my name, I'm Mati. I'm a subject matter expert here at Globant, and I'm based in the UK. And in this last session, we will use everything that we've learned in our previous three sessions about functional programming, the building blocks of functional programming, the patterns, and everything. And we'll try to combine everything into this session. So I hope you want to code today because we're going to be doing a lot of coding. The idea today is we're going to be grabbing a piece of legacy code and we're going to refactor it using TDD and functional programming. So buckle up. And before we do that, let me show you. Let's do a brief recap of what we've been speaking and we've been learning during our last sessions. And also in our chat, we're going to be sharing the link to our GitHub repository, which is here, where you can download the code that we will use for this session. Then you can follow along the coding, and you can code with me at the same time. So, all right, let's start with the presentation. Let's do a brief recap. All right, in our first session, we took a look at the building blocks of functional programming. Remember, we have types, we have values, we have expressions and functions, and we use these building blocks to create patterns, because using these building blocks, patterns arise. So we took a look at some of the functional programming patterns, like the functor pattern, the monoid pattern, the map reduce pattern, and the monad pattern. And we learned all about these patterns, how they work. We learned also some of the math foundation for these patterns, and how we can use them in Java. Then we started to look at what is the support in Java for functional programming. We have lambdas and optional, stream, completable future, and everything. And we even implemented our own monad, the result monad, which was really cool. So before we move on, I'm going to introduce one last concept, which is the concept of recursion, and then we'll start coding right away. Well, I'll introduce our tutorial and move right into the code because there is a lot of coding to do today. So, um, what is recursion? Recursion is a way in functions where a function can call itself. Like if you have, for example, the typical example that is used for this is the factorial function. The factorial is defined as a function using the same factorial function. So, for example, the factorial of a number is that number multiplied by the factorial of that number minus 1. And then you have the factorial of 1 and the factorial of 0, which are defined as well. But if you notice, the definition of the function uses the function itself. So when we talk about recursion, we're talking about functions that use themselves. And in our first session, I told you that Java doesn't have a great support for recursion. You can get a function can call itself up to a certain limit, and then you can get a stack overflow uh, exception. Basically, the stack call in the process gets full, the memory gets full, and you cannot allocate any more memory of the stack to create a new to create a new function call. So what you do, so what we're going to do is we're going to go around this by creating our own uh, function called stack in the heap of the Java memory. And if we do this, we can avoid the problem of recursion in Java. It takes a little bit more, but it will be very easy. So this is our tutorial. Our tutorial is a legacy delivery trucks package assignment software, and we have these packages. We have a list of packages that we want to assign to different trucks, right? So we have trucks that will deliver these packages, and because these packages have a weight, they have a volume, and they have a district where they have to go. And trucks have a max weight, they have a max volume, and they have the different districts that they visit. So, for example, package 1 can go to truck 1, and package 2 can go to truck 1, and package 3 can go to truck 1 as well, because they are for the same district, and they haven't occupied the truck in its fullness. So, but then package 4 has to go to truck 2 because it's a different district. So that's how this algorithm works. But this algorithm has been built in a legacy way. So we want to refactor it so that it has a more functional and declarative way, and we can see the difference in the code and see which one we like the most. And we will also be using TDD because we want to test this to make sure that we're not breaking anything. Right. No, this I'm going to the code right now. So I can see that the my friends at Globant have shared the GitHub repository. So um, you should be downloading that before you start. If you want to code along with me, if you just want to watch, just feel free to watch. Um, but yeah, we're going to be looking at our code and then refactor this code. So we have the class called the legacy delivery allocation service, which has a method called allocate packages to trucks. All right. So it receives a list of packages, and then we go to the database, we look for all the trucks, and we have some logic to validate that the trucks and the packages are there. So we have an if here, if the delivery packages is null, and we have all these conditions to check that we have packages and we have trucks. Now, what do we do here? We have a for loop here. We created a list of package allocations. So this is the result. We want to allocate packages to trucks. So we create an object which represents this allocation. And what else? So we have a for loop here, and this for loop goes through the list of packages, and it says we have a package allocation variable here, which is null at the beginning, and the delivery trucks here. We go through the delivery trucks for each package. We go through the whole list of delivery trucks, and we say if the district matches the district of the truck, and if the volume of the current volume of the truck plus the volume of the package is lower than the max volume of the truck, that means in volume it can assign the package. And then we can also check if the weight can be assigned. So by weight, we can also assign if all these conditions are met, then this code right here, we create an allocation, we update the truck so that we say, okay, now this truck has some more weight. It has a delivery package. So we update it and break the flow here. So this will end up this for loop. If there was no package allocation, we throw an exception saying, I wasn't able to allocate for this truck, right? And sorry, for this package, I wasn't able to allocate. And finally, we put all the allocations in the list and we return them. All right. So this is a very typical piece of code that we can find in applications that were developed in an imperative way. Um, we can notice that there are some refactors that we can do right away which are not functional. For example, this thing right here, we could probably create a method saying, um, can the truck deliver this package? So we can create that method. Um, there is a there is an well, we could also use another concept here because we're throwing an exception, but maybe there are packages that we can allocate. So if we cannot allocate some of them, why do we want to break this flow here? It would be better if we could, for example, create an empty allocation or something like that. So, and this involves using a concept called domain-driven language. Um, this we can create the concept of an allocation of an empty allocation and incorporate it into our domain, and we don't have to use the programming language tools. We, instead of using an exception, we create a new concept and we incorporate it into the flow so that we don't throw exceptions. Um, so far, so good. We have our model classes. For example, we have the truck, which I told you it has an ID, it has a max weight, a max volume, it has the current weight, the current volume, and the list of districts. We have the packages. We already also mentioned what are the packages. They have a weight and a volume and the district where they are destined to. Then we have um, the districts, which is an enum. This is a very simple implementation. And we have the package allocation, which is so, sorry. It has a delivery package, it has a delivery truck, and a status. So I think for now we have a good understanding of what is going on here. So because we want to refactor this and we don't have any tests because this is a very old code, we are going to create a new test for our service class. So to create a test, I'm using IntelliJ, so I can do Option Enter, and I can just click here on Create Test, and I can name it. It has already a name. I'll create this class. It already creates the class where it should be here in the test packet in the test source folder, and I'm going to if you downloaded this code, you'll notice I added these dependencies here. One is Mockito core, and the other one is Mockito JUnit, because I'm going to be using Mockito to mock some of the dependencies of my service. All right. So I'll start with test, and I'll say void test allocate. Okay, here we are. So now I'm going to um, I'm going to add here my class under test, which is the legacy delivery service. Right? You see, now I'm going to this class has a dependency, right? Because it has a delivery truck repository where I can find all the trucks. I'm not sure if you're familiar with the repository pattern, but it's basically a way to connect to a database. For example, you can create a repository class, and that repository class is in charge of connecting to the database. In our case, we don't have a class, we have an interface, and we're going to be using the, this interface. We're going to be mocking this object. So to mock that object, I'm going to simply say delivery truck repository here. And because I'm told you I'm using Mockito, I'm going to use the Mockito extension for JUnit 5. So I have to use this annotation extend with, and saying Mockito extension. Hopefully you're familiar with the concept of mocking, but if you're not, mocking is basically creating a fake object that will reply will when I call it with different methods, it will reply with the results that I want for that particular scenario. So I'm going to say mock here. So this will create a mock instance of this object every time. And finally, I'm going to say here inject mocks. So this inject mocks is going to say the mocks that we have in this test, inject them into this class. We have a constructor here, so we will use this constructor to create this class with the mocks. All right. So now I have set up my test class. Now I'm going to do a simple test. This simple test, I'm going to test the scenario in which I have this null check here. So if the delivery packages is null, I should expect an exception. So I'm going to say basically assert rows, and I'm expecting a runtime exception. And the piece of code that I want to run is basically the legacy delivery allocation service, allocate trucks, and I'm going to set null, right? So now I run this, it works. And I'm going to have uh, another case. I'm going to say here when null or empty. Okay, and I'm going to add here another case in which I'm going to say collections empty list. So in these cases, I expect an exception, right? So far, so good. Everything is straightforward. Now I'm going to copy this, and I'm going to test when the truck list is empty. When truck list is empty. So how do I get? I'm not sending the truck list here as a parameter. You see, that is a that is a dodgy thing. Like, and here we can notice that this is not a functional code, because if you're not sending it as a parameter, then where is it coming from? And it's coming from the repository. So what I'm going to do is I'm going to have to mock the the response of the repository. So for that, I'm going to use a method that comes with Mockito called given. So if I say given delivery truck find all, and I can import this as a static method. You see, it has been imported here. So given this find all will return collections empty list. It will return an empty list. So in here, I'm setting the expectations. So this is setting expectations. This step is also called stubbing. And I'm setting the expectations for my mock. So now I can say, um, I'm going to also create a delivery package because I want the exception to be thrown because of the truck, not because of the package. So I'm going to create a package with ID, let's say 1. What else? We have delivery package, we have weight, volume, and district. So let's say it's 100, and what else? District 1. Okay. And I have to put this in a list. So I'm going to use collections singleton list. So it's basically a list of just one thing. And I'm going to put this into a variable, delivery packages. So I'm going to send this, instead of an empty list here, I'm going to send the delivery packages. But remember, I'm expecting my trucks to be empty. So this will throw an exception. And I'm running all this. And let's see what happens. All right. Now we have these two tests. I'm going to create a new test, and now I'm going to be assigning. I'm going to be assigning a truck. So I'm going to say test allocate, and I'm going to, instead of returning here an empty list, I'm going to return a truck. I'm going to say collections singleton list, and here I'm going to say new delivery truck. And this truck will have ID, let's say ID 1, max weight 1000, max volume 1000, and the list of, let's say, district. It will only go to, no, it will go to district 1 and district 2. Okay. So what's wrong here? It returns, what is it saying here? What's the error? Delivery truck takes an integer. Missing parameters. So I'm missing the current weight and the current volume, which has to be 0 as well, because we just created the truck. So we'll put it in 0. Fine. So now I'm expecting this truck to be returned. So I'm not expecting an exception in this case. I'm going to expect something. I'm going to remove this as a throws, and I'm going to assign this to a variable. And this variable, oops, no, I want to assign the whole thing. And I'm going to say allocations. So set equals. First thing I want to say is there has to be at least one allocation. So allocate, not just one, or not at least it should be exactly one. We have one allocation, then we have we can say, for example, the ID of the truck that was allocated. Yeah, truck. Sorry, location get one, get zero. Delivery truck, and the ID should be this. And also, I can check, for example, the current weight. It should be 100, right? Because the package has 100. I could also check the current volume. Let's change the volume so that there is a difference there. And I can also check. I can also check for the package. For example, I could say delivery package and say get ID. And it should be one. So I'm going to run this and let's see what happens. Good. So even though our code is not very good, it's not pretty, it works fine. So at least that's something good. And what happens, for example, if I send if I have a truck here, but this truck doesn't deliver to District One, what is it that we expect in this case? What I don't know, but let's just try this. When District doesn't match, what are we expecting? All right, it threw an exception. So if I go to the code, um, right, if you code and allocate, because the district doesn't match in this case, we have to throw an exception. So this is what happens. So I'm going to, this is something that we actually want to change. So how can we change this? So we're going to be using a concept of domain driven language. We'll introduce this new concept of the allocation that is not allocated, if that makes sense. So to do that, I already have some code to do that, but basically what I'm going to say is I'm going to expect an allocation and it has to be one, and the truck in this case will be null. So I'm going to say assert null, right? And I'm going to say it like this. And what else? This will not be there because the truck is null, and the package will be the same. So now I'm going to introduce something else. Um, I'm going to introduce the allocation will have a status that will differentiate between an allocation being completed, allocated, and not allocated. And this we already have here. So I'm going to say um, get zero delivery allocation status. And in this case, it's going to say not allocated. And I'm going to add this assertion in our previous test as well, but in this case, it will say allocated. So in here, we are introducing this new concept of the allocation having a status and not being allocated, so that now instead of in here we are instead of having this being null, this being throwing an exception, what we can do is we can say package allocation equals not allocated. I created this method already, but basically it creates an allocation where the truck is null and it sets the status as not allocated. Okay, that seems very easy. All right, so now I have this not allocated, and now if I run this, if I run my test again, now I shouldn't be expecting an exception. I'm expecting an empty allocation. There's an error somewhere, so I cannot not allocate. Oh, sorry, I forgot here the delivery package. So now the not allocated receives the package that is not being allocated. So you see, this way we don't break this flow, and that is a very good thing because it's not really an error, a computation error. It's basically a business logic. So we don't want to handle business logics with exceptions. We can create business concepts to handle business logics. So you see, if I go here and I create another test, for example, where I have, let's say I have two packages, and one of the packages I'm going to say, instead of singleton list, I'm going to say list of, and I'm going to say this is ID 2, and this will go to district 2. So now I'm going to have, so you see what I did, right? I created a new test. I'm going to say when two packages. And in this test, I'm going to have two packages. And one of the packages is not going to be allocated, this one, because it doesn't go to any district that this truck goes. And this one will be allocated. So I'm going to have two allocations. And for the first allocation, which is the first package, it's going to be null and it's going to be not allocated. And now for the second, I'm going to do, actually, I like the assertions I had before for the, I'm going to copy these assertions that I have for my package. So for package number 2, for allocation number 2, I'm going to have this, and delivery package going to be get ID, going to be, no, not get ID, just ID, and it's going to be 2, right? Yeah, it's the second one that is assigned, not the first one. So this is everything that we're expecting. Let's see if it works. Awesome. All right. So any questions so far with everything that we're doing? We're just creating tests, and we had done the very first refactoring, which is just changing this so that it doesn't break the flow. So now you see, now we have created an allocation and we haven't break the whole flow because we don't have one. We basically skipped one. So this is a very good way to make our processing more efficient. Um, all right. So now let's let's take a look. I think we have some enough tests to start our refactoring. So what can we do here? The first thing that I want to do is this thing here. The fact that we're getting something from the database and that we don't know what it is. And we don't know this, like this could change all the time. So I don't we don't like these kind of things in functional programming. Of course we had to keep it somehow because we had to access the database, but what we will try to do is we will isolate the logic of getting this, which is a side effect, we'll isolate it in the service, and we will extract this other logic here into another place. So this logic here, I want to extract. So first thing I'm going to do is I'm going to extract this as a method. And I'm going to just call it allocate. So this method, you see, it takes delivery packages and it takes delivery trucks. And it doesn't depend on any state from the outside. It doesn't depend on the database state. It just does something. So if I run the tests, because I did the refactoring, everything should work the same. Mhm. It works. All right. So now I'm going to move this into a separate class. Because I just want to have it separately where I can edit more things. I'm going to just call it I'm going to call it functional allocation strategy. Okay, and I'm going to basically move this method here in the functional allocation strategy. And because it's private, I'm going to put it as public. And I'm going to add this guy as a dependency of our legacy code. So I'm going to say private final um, functional allocation strategy. And I'm going to add this into, I'm going to initialize it in the constructor. I'm not going to inject it. Okay, avoid some issues with the mocks. And because we have this now, I'm going to use it here. Sorry, allocation strategy. You see, I'm now using the allocation strategy to call the method allocate. And lastly, I will remove this method from here. So this goes away. This class has drastically changed. Now it's very small, but if I run this, I should have still the same results. Yes, you see? Because the code is still there, but it's in a different place now. So now this is now just by looking at this, this is more functional because it takes parameters and it returns something. But it's not enough. Um, one of the things that we want to do is we want to think of this logic more functionally. So one of the things we have here is this these for loops, right? We have these for loops. We have this variable here that is being created. Um, you see, we have this variable here as well. This helper variable. We have a lot of different things, and we update things. So we update the truck. This is something that we don't want to do because we are modifying something. We're losing the referential transparency that we want to accomplish with functional programming. So um, since we don't want to do all this, well, what things did we learn to to be able to do iterations and transformation across multiple objects in a list? Do you remember anything that we've done for that? we can use the stream API, for example, and we can iterate things with the stream API. So we can replace our for loops with the stream API. And another thing that we can use here is we can use the concept of recursion. Why am I telling you this? Because if you notice, um, this code basically takes a package and does something with the package and then returns that something. And then we want to do the same for every package. So we could say that this is a recursive operation. We have a list of packages. We take the first one, we assign it, and then we take the remainder list and we send it back again to be assigned. You see how this is a recursive thing? So we're going to be using recursion in this case to implement this logic which I'm telling you, where I take one package, I assign it, and then I get all the remainder list of the packages and assign them as well. So I will call the same function, and the function will again take the first package, assign it, take the remainder, and send it again, and so on until when? It's until we finally uh, have no more until we have no more packages, basically. So I see there is a comment saying, wouldn't recursion increase complexity? I guess it will increase the complexity. I mean, if you think about it, it might be not very intuitive at the beginning, but eventually you'll see it as a more simple implementation. So we'll see how that goes. So the first thing I'm going to do is I'm going to create a new version of this method. So I'm going to just call it allocate. I'm just saying two. All right. And um, recursive methods. All usually there are different ways to do recursive methods, but the way I'm going to do this is I'm going to create a helper method called do allocation, and this method is where are this if I create this method here, I want you to to be able to see. So why am I creating this helper method? Because I want some place where I can store the intermediate results. So this method do allocation will allow me to store the in memory the intermediate results of the allocation, so that when I finish everything, I can have the whole thing in the do allocation method. So let me show you how this works. The do allocation method will take the list of packages. It will also take the list of trucks, and it will also take the current result. What is the current result for now? This is basically the current result is going to be an empty string for now. Why? Because we don't have anything. We haven't assigned everything. But this is going to be an empty stream of um, allocation, something, a new class that I want to create called allocation result. Oh, sorry, no, we do have that. We have the package allocation, right? We have the class package allocation. We have delivery package, delivery truck, and so on. All right. So we use and we create an empty stream because we don't have any allocation done yet. And this is, we are going to create this method right here. Packages, trucks, and allocations. Okay. So now, remember when we are talking when we are talking about recursion, we have to define the function for the limit scenario. In this case, is when we run out of packages, what do we do? When we run out of packages, we just return the whole allocations. We don't have anything else to do, so we just return this. So this is what we'll do. If um, if packages is empty, return allocations to list. Right? This is the first thing we're going to do. This means that we don't have any packages to allocate. So it means that we have all the packages already allocated in here. So we can finish the operation. We're starting in the end, but that's why it's a recursive function. So now that we have handled the limit scenario where the packages are empty, we have to assign one package. So we have here some logic. How do we assign packages? You see, where is this? So we have one package here, right? In here we have took one package, and we are going to go through the list of trucks. So in here we are going to be using stream. So I'm going to have the list of packages. Where is it? The list of pack. So I have the list. I have the list of packages. I'm going to take the first package first. So I'm going to say packages get 0. And I'm going to say package. Yeah, a package, because package is a keyword in Java, so I cannot use package. I can use a package, right? So now I have the first package that I'm going to use, and I'm going to allocate this package. So how do I allocate it? I have the list of trucks, remember? So I can stream the list of trucks, and I can filter the trucks with this condition right here, right? But I don't like this condition written so wide. So I'm going to be creating a new method in the truck, and right. So we have this method already created. I already created it, but this method basically is called can deliver package. This is a refactoring that I already did, and it uses three helpers method. And you see how clear this thing is. It's way more clear than what we saw in our service. You see, we have this thing. I don't know what's going on here, but if I read the method in delivery track, I can say, can the truck deliver this package? And I'm saying it doesn't exceed the max volume, it doesn't exceed the max weight, and the district is included. It's really, really easy to understand. So I'm going to be using this method instead of that uh, whole condition here. We always need to because we're chaining conditions here, and we are we're not very I'm not very good at logic. For example, when I have to process it in the moment, and I have to think, okay, this and this or that, and it has to be greater than, and there's a lot of conditions going on here. So I like to abstract those conditions into simpler things so that I can understand it. That's why I created this method. So remember, we have the list of trucks here, and I'm going to filter the truck. Uh, can deliver package, a package, right? So now I have all the trucks that can deliver this package. And basically, I'm going to say find first. I want the first truck because we're keeping the same logic here. We're finding the first truck. And with the first truck, I'm going to um, I'm going to map this into an allocation. All right. So you see what this is exactly what we do here. Once we find a truck, we find a truck, uh, and if we can find this truck, we map it. We create an allocation. So I'm going to say um, truck, and remember, find first returns an optional. That's why I'm doing map here because I'm assuming the truck exists, but then I'll handle the scenario where the truck doesn't exist. So we're using not only stream, we're using optional. Remember? All right. So truck. We can we'll have to do package allocation allocated, and we'll send the package and the truck. All good. Um, there is one more thing that I want to do here because um, if I do this, I'm not updating the truck. Remember, we need to update it. We do an update on the truck. We're saying that this truck has to be updated with the new weight and the new volume. So we don't want to do that in functional programming. We don't want to update things like that. So what do we do? What we're going to do is we're going to create a new method in truck called allocate, and we'll send the delivery package. And this method will return a package allocation. So this method already exists, but I'm going to be writing it again. Right? So I'm going to write it again. I'm going to say create method. So I'll say that it will return a package allocation and it receives a package as a parameter. So what do we want this method to do? We want this method first to update the truck. So in functional programming, we don't update things. We create new things. So I'm going to say new truck state. I'm going to create a new delivery truck. And it will have the same ID. It will have, I'm not going to say this, I'm just saying the ID, the same max weight, then the same max volume. Now the current volume, the current weight should be current weight plus a package weight, right? And what will be the current volume? It will basically be the the current volume plus the package volume. And these tricks will remain the same. So we have the new state of the truck. So I'm going to say delivery truck. I'm going to say new truck state. And I'm going to create an allocation now. Package allocation, the allocated, and I'm going to send the new state, the package and the new state of the truck. Okay, following along? Any questions so far? You understand why I'm doing this? Why I didn't want to update the truck and instead I'm creating a new truck? If you have understood, then all good. Let's move on. Right. So we have now a package allocation. We are going to we have to do something else. We have to update the list of trucks somehow, right? Because now we have we have a list of trucks that is uh, out of date. The list of trucks doesn't have the new state of that truck. So I'm going to create another object. I'm going to be using another object here, which will contain the new list of trucks. Uh, and I'm going to say create allocate allocated result allocation result, and I'm going to send the allocation and the old list of trucks. So I'm going to create this new method here, and this will return a new object called allocation result. This allocation result is an object that I'm going to create here as a record, because this is a helper object. And it will have a package allocation, and it will also have the list of delivery trucks. I'm going to say new state of trucks, right? So remember, why am I doing this? I'm doing this because I want my list of trucks to be updated. So because I don't want to actually modify the list, I'm going to um, create a new list with the trucks. So now that I have my allocation, I need to handle the scenario in which the allocation didn't happen because it didn't find a truck. So how can I do that? I can use optional method or else get. And with this, I'm going to basically do what I did when I don't have an allocation. I'm going to do this. All right. So this when I wasn't able to create an allocation. I'm going to create an empty allocation. So I'm going to say here empty package new allocation result. But in this case, it's going to be package allocation not allocated, a package, and the list of trucks will be the same list of trucks, right? So this there was no change in the list of trucks, so I won't change it in this case. But I haven't implemented this method yet, so I need to implement it. So how do I update the list of trucks? Very simple. I can basically say trucks stream. I can I can say map. And what I'm going to do is I'm going to basically say if the truck I have allocated is the one that is here, I'm going to replace it with the new state. Otherwise, just keep the same truck. So this is the condition. I have a truck, and I'm going to say truck get ID equals um, allocation truck get ID. If the truck is the same, I want the new truck. So I'm going to say allocation delivery truck. Otherwise, just keep the same truck. And and then I have the list, new list of trucks, and I'm going to return this new allocation result, new list of trucks. So you see, the old list of trucks never changes. The only one that is changing is this one. And because this method is already too big, well, I'm going to assign this into a variable. So I have the allocation result here. But because this method is quite big now, I'm going to choose extract it. Let me go back again. I select the whole thing, the whole pipeline, and I do option command M, and I have a new method extracted. And I'm going to just call it allocate single package. Right? All good? So now I finally, what else do I need to do? I have allocated one package now. What I need to do is I need to get the list of all the whole packages, remove the first one, which I have already allocated, and go on with the rest of the list. So I'm going to get the pending packages, saying packages sublist one and packages size. You see what I'm doing here? I'm having I'm removing the first element of the list. So this is the pending packages. And I'm not modifying the existing list. This is creating a new list. So we are always keeping everything referentially transparent. Everything we're keeping unmodifiable because we are functional programming. So we have the pending packages. What else do we need to do? Now we need to call this method again, but with the new data that we have. So we have the new list of packages and we have the new list of trucks. So very easy. We basically say return, do allocation, packages. We have in the allocation result, we have the new uh, state of trucks. And finally, the allocations inside here, we also have the actual allocation in the allocation result. You see, we have the actual allocation. So what we're going to do is we have received the allocations here, the ones that we currently have. At the beginning is empty, like we saw here. At the beginning is empty. So what do we do with this? We basically concatenate. So we can use stream concat, and we can say um, the current allocations that we have, and we are going to concatenate this to the new allocation. The new allocation is in here in the allocation result. So allocation. Oh, this is not a stream, so I need to do stream off. So we have added this element to the stream now. And oh, here I forgot. We need to send the pending list of packages, not the old list, the new list, the list which has less packages in it. So this might be a little bit confusing at the beginning, but if we look at this method and we look at this thing here, this is way easy to understand. Basically, I'm saying if the list is empty, then return what we have. Now get the first package, allocate the first package, remove the first package from the list, do the allocation for the rest. It's way more simple. And this part here as well, we have the track. This part would represent this here. All this code here is this. So we have track. We filter the tracks that can deliver. In here, we would do that filtering using this if here, which is really ugly code. We cannot understand the conditions here. But in here, we don't have to understand the conditions. We just simply know there is a method that can tell us if this package can be delivered. We get the first one, then we allocate, then we create the allocation result, and if we weren't able to allocate, we create an allocation result for a not allocated package. You see how declarative this is. You see how this is a more declarative approach. I see another comment there saying, is recursion a common approach in functional programming? It actually is. It's really common. Uh, most functional programming languages, pure functional programming languages, don't have loops like fors or whiles. So they use recursion heavily. In Java, we don't use recursion that much because the language is not very well prepared for recursion. So we'll have to do something again after this, just to make sure that we are covered for all scenarios. But we have finished our refactoring, if you noticed, and I can basically replace this method. I'm saying allocate here, and I remove this thing here. If I remove this, and what else? What do we have here? I think everything is fine. So we should run our tests basically. Yeah, there are a few things that we haven't checked here, which is we need to check if these things are not null that we did in our previous code. So I'm going to create quickly. I'm going to check. This is really easy. You can use objects, require non-null, delivery packages, and you can also say object require non-null for delivery trucks. And if I'm not mistaken, in our service test, we need to change the exceptions, because now there won't be runtime exceptions, there will be null pointer exceptions. So we change this here. And we also want to check that these things are not empty. So we could say if delivery packages is empty, return. We don't really need to throw an exception if this is empty, right? Because basically we won't do anything. It won't do. It will return an empty list of package allocations. That's it. So why do we want to throw an exception? We need to change that behavior. And the same goes for delivery trucks. And actually, we can do this even in the cases of null. So we could send here um, a supplier that will return the actual, no, not this, objects require non null or else. So, or how is it called? Yeah, non null else. We can use this and set it as empty in the cases that it's null. So we can say collections empty list, collections empty list, and actually we should do this in our in the method that is calling this thing, so that we can keep all the validations and all the non-functional stuff here. So we put it here and we say empty list. We could call it delivery. We can assign it again to delivery packages. And again here we can assign it to delivery trucks. So in here we have kept all our non-functional stuff. And in here we have kept everything that is functional, because since Java is not a pure functional programming language, we cannot keep everything functional. I'm going. There is another question saying, is it good? Is it a good idea to use a library like BARB for functional programming in Java to have try either option? Um, I have seen this library and I tried it before. Um, I haven't used it. I think if you really want to do it in a very very functional programming way, it's a good library. You can use it, but I haven't used it personally. I think it's a good library, and it's used to make Java even more functional. So I think it's a good library, but it has limitations because the language itself has limitations for functional programming. So I find it that it might not be super useful, but I really like what they have done with that library. And so I think, so where were we? Yeah. So we have kept all our non-functional stuff in the service. So now we have some tests that won't fail, but will return empty things. So in the case, for example, where we're not expecting exceptions here, I'm going to remove this and I'm going to say here package allocations. I'm going to say assert equals. I'm going to expect size to be 0. And the same here. If I do this with an empty, I do this with an empty list. What is it? Allocations 2. Right. I remove this. Remove this. Have this, and I can assert as well that these allocations 2. I'm going to say allocations 1. This will be empty and not null, and it won't throw exceptions. So, and this again, going to have this into a variable, and this should be empty and not throw exceptions. So equals allocations size should be 0. And let's run our tests and see what happens. Right, so most of our tests worked just fine. There's one that is failing. Um, oh, right, so this is not zero. This is an empty allocation in this case. So I should, because this wasn't able, because the list of trucks is empty. He has tried to allocate it, but it's an empty allocation. That's good. That's actually what we want. So now we should check, for example, allocations get zero, and we can check the status, and it should be not allocated. So let's run everything again. And yeah, everything works just fine. So you see now how we have moved from our legacy code into this. Did you um, what were your thoughts? Do you like this new version of the code that we have? I think it's pretty cool. I think it's a very good refactoring that we did. It's way easy to understand. It's easier for me, at least. It's easier to understand now what's going on. And what I'm going to do now is I'm going to tackle the fact that in Java this could go really wrong because of the recursion limitations of Java. So um, how can I do recursion in Java without having the Stack Overflow exception? I can do I can do the recursion um, in the heap, so I can have my own recursion stack. I will create that. So I'm going to create a new class. I'm going to say, for example, utils recursion call. Okay, and it's going to be an interface, and it's going to have a type, right? So this will represent our recursion call, so that we don't have to use the actual Java stack to do the to. So this will effectively turn our recursion into a loop. So what do we do here? So first, our recursion is going to be a functional interface. So it's going to have one method that will only one method that can be implemented. The only method that can be implemented for this interface is a function that will return a recursive call, and this method will be called next. Okay? Now I'm going to create a new method, which is a boolean, and it's going to say is done. And this method will tell me if we have new calls to do, or if that's the last call. So by default, we will always have new calls, um, because we will have a different implementation of this. I'm going to create it right now. I'm going to create it here as well. So interface, and I'm going to say final call implements recursion rec call, and um, this is going to implement because this is the final call of the recursion. This is going to be the isDone method is going to be implemented in a different way, and I'm going to show you afterwards. Then we have the value, the get value method, and this get value or we can call it just get. This get method will return the result of the whole recursion. But because we are in an intermediate state here, we're going to just say um, throw new illegal state exception. Or so actually, to make it more clear, I'm going to do like we did with the monad in last the result monad. I'm going to create two implementations and with no default methods, so that is more clear with you. Um, so this will not be a functional interface, and this will have that, and so it has the get method, and then we have the apply method, which also returns a, value, and finally, yeah, that's it. And we'll have two interfaces. Sorry, two implementations. One implementation will still be an interface, which would be recursive. Say, let's call it intermediate call. Extends because it's an interface. And this is going to be a functional interface. And it will have this method right here. And the rest of these methods will be implemented. Even though it's an interface, I can do default. I can implement these methods. Why do I still have this as an interface? Because I want this next method to be implemented as the method call, and you'll see it in just a moment. So in this case, return false because we are in the middle of something, so it's an intermediate call. In the case of get, the get value will not return anything as well because we're in the middle of the call. So we're going to say throw. We don't want the get call to be the get method to be called. Intermediate call can't return a value. And then we'll implement here. This is not an interface. This should be a class. And this class will implement all the different methods. So next will not have an implementation because next will have we don't have a next value because we are the final call, right? So I'm going to say final call and have next. Also, because this is a class, this will have a value as a member. I can make it a record actually and put it here, the value. So now we have this class here implementing this interface and it has a value. Is done because it's a final call. We're going to say true. Then we have get, which is a method here. We're going to say value. It will return the actual value, and apply will not be implemented because we will have a default implementation for apply. So we don't we don't need to implement it, right? Um, no, I'm going to implement the apply method at here at this level, at the top level, because we want the same implementation for both. Right. Going to remove the no. I think I will have to remove this interface, this intermediate interface, because this has made this a bit more complex. But I think you get the idea now that we have this interface. I can remove it and just use the other one. So I'm going to remove this. I'm going to have it implement directly here, so I can have it as a functional interface. And this is important because I want to implement this as lambdas. So I'm going to have this as a functional interface, have this, and this default method. I want to implement this. So now here's where the magic happens. In the apply method, I'm going to run the recursion. So this is how we're going to do it. We're going to create a stream, and the the seed for the creation of this stream will be the recursive call. So I'm going to create a recursive call, and the method that will generate the next element will be called basically uh, next. Okay, so this next method will call the next recursion. Then I'm going to filter and just keep the one when it's done. So I'm going to keep filtering this stream until I find the final call, because only the final call will return is done. Remember? And then if I find any, and I can say map rec call dot get. So because I am in a final call, I do have a get, right? I can do the get here. And lastly, if I have a problem here, if I haven't had a final call, I'm just going to throw an exception because this shouldn't happen. I should always have a final call. A new runtime exception and recursive call, uh, recursive final call never found. Okay. So now, how do I adapt my code to be recursive? I'll go to here. To use this kind of recursion, I'm going to simply say, I'm going to create another method here, two helper methods to create recursive calls. Static rec call t, which should be t. I'm going to call this count from continue, and I'm going to say this will take supplier. Oh, sorry. Recursive call. It takes a recursive call. And then I'm going to say next call instead of, and the other method will return a final call. I'm going to say rec call. We don't want the user to know this, but I'm going to actually return final call. Return new final call value. Okay, so we're almost done here. If I go to our functional allocation service, Now I need to change the return type of this. I'm going to say this is a recursive call. And now this will return. In the case that we have nothing else to do, we'll return the final call. So rec call stop and the actual result. And in the cases we have something to do, we'll continue and we'll provide this as a lambda implementation. So this will be implemented. This will implement the rec call interface because it has the next method which takes no parameter. You see, this is implementing that. And now I can I had to call the apply method here so that everything runs. And now it's everything will run instead of running in the Java stack, it will run inside a stream. So it will run in a loop, in a for loop. And I will avoid the exception, the and I will also avoid performance issues. This will be more performant than the old implementation. So I'm going to the test now, and I'm going to run everything. Missing return statement. I forgot something here. I have to say return. Yeah. So we are in the rec call. I forgot to put the return value here. All right. So running this, and everything passes. Incredibly, everything passed at the first try. So really, really well. So this is really exciting. So because we can now use recursion in Java, which we couldn't, and so you see how we have implemented this recursive call now. Do you have any questions regarding this? Um, let me know your opinions about the code that we have generated. So we have made sure that everything runs. We have the tests. We have done this refactoring in a TDD way. So I think you will appreciate that this is a very very nice piece of code now. We used to have an old ugly code with a lot of for loops and some helper variables and things that we didn't understand and exceptions being thrown anywhere. And now we don't have any exceptions. We have a lot of nice code, new concepts. Um, so I really appreciate this refactor. I think it's really nice. So all right. I don't know if you have any questions for this session, or even questions that you may have from older sessions. But I think we have had a great fun doing this. I certainly had a lot of fun doing this with you guys. It's been amazing. Uh, Everything that we have accomplished, we have learned a lot about functional programming, and we were able to take an old piece of code, which is really ugly, into a more functional way. So I think we have put into practice everything that we have learned. And before I go, I want to thank you, all of you, who have watched all the sessions, who have been there in all the live streams, or people who have watched the sessions afterwards, the recorded sessions. Thank all of you. If you like this content, please give us your feedback. There is a link here where you can scan and you can complete a feedback poll where you can tell us everything that you thought about these live stream sessions. You can tell us which other subjects you'd like to see in the future. So we're really looking forward for that feedback so that we can improve and we can give you guys better content. So thank you. Thanks to Globan for this space. And if there are no more questions, then I'll leave you guys. I hope you had a great time, and we'll see you probably in the future sessions. So, bye.